Hello everyone, this is Sakshi and I welcome you all to my edutech platform, Way to Learn. We are going to see problems from mathematical physics and a new topic from mathematical physics which is matrices. So in this video, we are going to see a lot more properties of matrices which are going to help you solve problems in few seconds. So these properties are going to help you a lot, so please make a note of those properties and it could be a revision for those who know already. So this is a basic definition of a matrix, and here we write this as Aij, where Aij are the elements of the matrix, and M and N are the number of rows, M, and N is the number of columns. Let us see the types of matrices. So the first one is the square matrix, where the number of rows are equal to the number of columns, and the diagonal matrix is the one where the elements other than the principal diagonal elements are 0. That is, except the diagonal elements, all the elements are 0. Scalar matrix is also a diagonal matrix whose diagonal elements are same. That is, the diagonal elements can be 5, 5, 5 or 1, 1, 1, 2, 2, 2. They will be same. Identity matrix or unit matrix is also a diagonal matrix whose diagonal elements are equal to 1 and all other elements are equal to 0. And row matrix is a matrix having only one row. Column matrix is a matrix having only one column. Null matrix is the matrix which has all elements equal to 0. And upper triangle matrix is the matrix whose elements below the principal diagonal elements are 0. And lower triangular matrix as shown here, whose elements above the principal diagonal elements are 0. Let us see these four different matrices, where periodic matrix is the first one. It is a square matrix. Here we will be seeing all the square matrices because they are very easy to solve. That is, the number of columns will be equal to the number of rows in a square matrix. So we are going to consider square matrix. So the square matrix whose like if you find a square matrix and uh, if you take some kind of power, that is a cube, and you get back your same matrix as given in the question, then you can write that power cube as k plus 1, which is 2 plus 1. So such kind of matrix is called as periodic matrix, which says that it repeats itself. The matrix repeats itself with a period given by k. Next is the idempotent matrix, where if you square the matrix, you gain the same question. That is same matrix as given in the question. That is A square is equal to A. And nilpotent matrix is a matrix for which A power P will be 0. That is, if you take a square of a matrix or fifth power of a matrix, and if the elements are 0, you get a value 0, then that particular matrix is called as nilpotent matrix, and this P is called as the index. Whereas above in the periodic matrix, K is called as the period. That is, it repeats itself for a period K. Okay, so next one is the involutory matrix, where A square will be equal to I. So in idempotent matrix, A square will be equal to A, and involutory matrix, A square will be equal to I. Let us see the symmetric matrix, where A transpose is equal to A, and skew symmetric is the opposite, that is A transpose is equal to minus A. Hermitian matrix is the matrix whose transpose conjugate will be equal to A. Transpose conjugate is nothing but you have a matrix, you're going to take the transpose of the particular matrix and then take the conjugate. Conjugate are taken only for those terms which contain the imaginary term, that is I. So if the element has I in its matrix, then you can change the sign, that is called as conjugate. And skew Hermitian matrix is A dagger is equal to minus A. Here this plus sign above, that is for Hermitian and skew Hermitian, you can also call that as transpose conjugate or a dagger. So here A dagger is equal to minus A. And singular matrix is the matrix having 0 determinant. So if your determinant is 0, then it is said to be singular matrix. And for a non-singular matrix, determinant will not be equal to 0. Orthogonal matrix is the matrix which satisfies this property, which is A transpose is equal to A transpose A should be equal to I. I is the identity matrix. And the unitary matrix is the one which satisfy A dagger is equal to A dagger equal to I. So let us see the adjoint of the matrix. You can find the adjoint of the matrix by taking the transpose of the cofactor matrix. So you have to find the cofactor of your given matrix and then take the transpose. That gives you the adjoint. Next is the inverse of the matrix, which is given by this following formula. A inverse is equal to 1 by determinant of A, adjoint of A. Remember, first you have to find, the first step to find the A inverse should be, you have to take your determinant first. So if it is equal to 0, then A inverse will never exist. So you have to find your determinant first. If A determinant is not equal to 0, then it will be a non-singular matrix and inverse exists, and you can find by using this formula. So this is the eigenvalue equation we basically use to find this equation. This is also called as a characteristic equation. And this lambda is called as the eigenvalue, and x1, x2, x3 are called their corresponding eigenvectors. So basically we find using this equation the eigenvalues of the matrix. I hope you would have studied this in your MSc first year. And this is the Cayley-Hamilton theorem. And yeah, just remember that n cross n matrix has n eigenvalues. That is, if you have 2 by 2 matrix, then you'll have 2 eigenvalues, and if you have 3 by 3 matrix, you'll have 3 eigenvalues. So let us see some properties of eigenvalues. Trace of the matrix is equal to the sum of the eigenvalues. So if you have found the eigenvalues, then if you sum them, it will be equal to trace. What is trace here? Trace is nothing but the sum of the diagonal elements of the matrix. So if you sum the diagonal elements of the matrix, it will be equal to the sum of the eigenvalues. This is an important property which will help you solve problems in few minutes. That is in few seconds. Okay, next property is the determinant of the matrix is equal to the product of the eigenvalues. So if you have found the product of the eigenvalues, then that would be equal to the determinant. And next is the characteristic equation. So if you have we basically write the characteristic equation in a very long term, like we have to find a square term, then a cube term, whatever it is required. But basically, if you have to form the characteristic equation, you can use these two equations where we know we can find the trace and determinant, and also here C1, C2, C33 are the cofactor terms. So you can also find the cofactor and substitute over here sum of the cofactor. So these characteristic equation can be directly used in a formula instead of a long workout. Okay, so next, if you have found an eigenvalue of matrix A, which is lambda 1, lambda 2, and lambda 3, then the eigenvalue for the inverse of that particular matrix will be 1 by lambda 1, 1 by lambda 2, and 1 by lambda 3. And if that matrix is power n, that is, if you have eigenvalues of A and you have asked to found the eigenvalues of A power n, then it is direct. You can just power the values of the eigenvalues of A. Lambda 1 the whole power n, lambda 2 the whole power n, lambda 3 the whole power n. So it's just easy. You have to remember these properties. You can remember directly. You don't have to like mark it up. When you solve the problem, you can just, it will just remind you that okay, you have read something somewhere. Okay, so next is every square matrix satisfies its own characteristic equation. Okay, so next is the eigenvalues of the Hermitian matrix is real. So Hermitian matrix or symmetric matrix. So just remember the eigenvalues of Hermitian or symmetric matrix are real, and the eigenvalues of skew Hermitian matrix and skew symmetric matrix are either 0 or purely imaginary. Also, the eigenvalues of a real orthogonal matrix or a unitary matrix are of unit modulus. So, if you take the eigenvalues of that particular matrix, orthogonal or unitary matrix, and you find the mod of that eigenvalue, you are going to get 1. And next is the two similar matrices will have same trace and determinant. If you have two similar matrices, then and a question is given like, okay, they say that matrix A and matrix B are similar by similarity transformation, and then they have given trace for one similar matrix, and also the determinant of this determinant also be the same. Then you have asked to find the trace and determinant for the other matrix, that is matrix B. We already know that A and B are similar by similarity transformation. then obviously the trace and determinant of both the matrices will be same. Hence, if it is directly given in the question, you can just use this property and write the same trace and same determinant. So next is if you have a matrix, n by n matrix, and if all the elements are equal to 1, that is all the elements a11, a22, a1, a21, a23, a31, everything, all the elements in that matrix are 1, then how do you find the eigenvalues? The eigenvalues will be equal to the order of the matrix. So if the order of the matrix is 3 by 3, then one of the eigenvalues will be 3 and all other eigenvalues will be 0. So just remember, if your matrix has the element 1, that is all the elements of that particular matrix is equal to 1, then eigenvalue will be equal to one of its eigenvalue will be equal to the order of the matrix. That is 3 by 3 matrix, then in eigenvalue will be lambda 1 will be 3. If it's 4 by 4 matrix, lambda 1 will be 4. And all other eigenvalues are 0. And next is if you have the same like n by n matrix and you have rows and columns. If a row and a column is a scalar multiple of other row and a column, that is the first row is 1, 2, 3 and the second row is 2, 4, 6, then it is a scalar multiple of the second row, right? Then such kind of matrix will have trace as one of its eigenvalues and all of the eigenvalue will be equal to 0. So these two are going to help you a lot. You just have to remember this, revise this daily so that you just remember this, because you can have questions, tricky questions, and you're stuck with a 4 by 4 matrix finding the eigenvalues. You can better use this following property if it helps for that particular question. So next, this is an important topic where such kind of questions, that is if a question is asked to find e power a, that is a is a given matrix, 4 power a, cos pi a, sin pi a, anything. So usually one has to find this by using diagonalization method. If you had studied this in your BSc or MSc, diagonalization method is a very big process to do. So this is a small trick where it will be helpful for you to find the solution for such kind of problems. So how do we solve such kind of problems? So you have to find the eigenvalues of that particular matrix. That is the first step. And then use e power m is equal to alpha 1 m plus alpha naught I. This is a constant equation. Instead of e power m, you can use what is given in the question. You can have 4 power a, cos pi a, or sin pi a, or anything what is given in the question. So this is the form alpha 1 m plus alpha naught I, and it is equal to some equation which is given in the question. And here alpha naught and alpha 1 are the constants and m is the matrix. I is the identity matrix. Now the next step is to replace this m by the eigenvalues. That is e power lambda will be like I'm replacing it by the eigenvalues, which is e power lambda equal to alpha 1 lambda plus alpha naught I. And then after replacing, you get many equations, like 2 or 3 equations based on the eigenvalues, and you can find the values, that is constant values, alpha 1 and alpha naught. After finding the constant, you have to directly substitute in this particular main formula, and this will help you find the solution. So this is going to be a very easy problem to solve. Like such kind of problems if you have, you can use this method to solve that particular problem. So now we have a matrix M which is 2, 1, 1, 2, and I have to find cos pi m by 6. So I'm going to tell you how to use the previous solution. So first thing is to find the eigenvalues, and my eigenvalues are like 3 and 1. Lambda 1 is equal to 3 and lambda 2 is equal to 1. Now I have to find cos pi m by 6. So I write the main equation, which is alpha 1 m plus alpha naught I, and instead of m I'm replacing it with the lambda values, that is cos pi lambda by 6 equal to alpha 1 lambda plus alpha naught, and when lambda is equal to 1, my alpha 1 plus alpha naught will be root 3 by 2, and when lambda is equal to 3, my alpha 1 plus alpha naught will be equal to 0. From this I can say that alpha naught is minus 3 alpha 1, and using the first equation I can say alpha 1 is equal to minus root 3 by 4, and then alpha naught is plus root 3 root 3 by 4. So these are the values of alpha naught and alpha 1. So now next step is to substitute the values of alpha naught and alpha I in the main equation. to find the solution. So we are going to substitute in this main equation where I'm in instead of alpha 1 I'm using minus root 3 by 4, and instead of alpha naught root 3 3 root 3 by 4, and instead of m I'm using the matrix as given in the question, and I is identity matrix. Now just simplify this. You're going to get the value of cos pi m by 6 root 3 by 4 of 1 minus 1 and 1. So this is a very easy solution for such kind of problems. You'll find this easy, and you can see like you'll have question based on this. Obviously in the previous year, this is also a previous year question, so you can find the previous year question based on this topic. So this is your homework problem where I have given a matrix A, and you have to find the eigenvalues of this following matrix. So this is so big, right? You have to find A cube, A square, and find their eigenvalues and so on. A simple thing is use the properties. The properties that I have already mentioned for the eigenvalues, you have to just think of those properties, how to incorporate in this solution. And then I have also for your for your easygoing, I have also given the eigenvalues of A, which is 1, 3 and minus 2. Now for each eigenvalue you're going to substitute in this following equation, and you're going to get the uh, answer for this characteristic equation, that is the eigenvalues answer for this characteristic equation. So here we have 3 eigenvalues, then you'll have 3 answers. So just try to use the property, and it can be done in like few seconds, 20 to 30 seconds, that's all. So you can do this very easily. Just try to use the properties in this equation and find the eigenvalues of that particular equation. And let us see the solution of the previous problem, which was from vectors. I have already given that v1, v2 and v3 are given, and I already said that they are linearly dependent. And now we have to find the value of alpha. So we know that for linearly dependent, the box product is equal to 0. So I have directly taken the determinant, and I just found the determinant and equated to 0, and alpha will be 31 by 4, which is option A. I hope you find this topic to be very easy, and the matrices which I have all told you now, which is going to be very helpful for you to solve problems. And obviously we are going to get at least one question from matrix. So I hope you like this video. So thank you. Like my videos, share my videos, subscribe my channel, and also hit the bell icon. When you hit the bell icon, you're going to get notifications of my videos. And stay tuned for more videos for the PYQs of mathematical physics, classical mechanics, and also for a new topic in mathematical physics and a new subject. It can be anything from the 9 subjects. So see you tomorrow. Ta-da!